Okay, today we're going to be talking about how to solve chemistry titration problems. And these are very similar to any other dimensional analysis problems or stoichiometry problem. You start with the information given in the problem, and then you work your way to what you want, what the goal is here. And here's the goal is molarity of the solution. So the first thing you want to do is balance your equation. And so if you notice that you have one barium on each side, two oxygens are required on each side, so I have to put a 2 here. 4 hydrogens, so you need 2 more hydrogens here. 2 chlorines, you're balanced. I like to write the given information underneath each chemical because it can be confusing. Sometimes you can write it backwards and then you're confused. So I'm going to write the given information from the problem just right underneath the compound in which it belongs. And then I'm going to say I'm looking for molarity. Keep in mind that molarity is moles of solute per liter of solution. And again, solute is just the thing that you're adding to. Typically it's water, but not always. All right, so you're starting with this information and you want to go here. The main thing to remember that you would have used this formula before. You've probably seen this in dilutions of solutions. However, when it comes to titration, you have to take into account the fact that there's not a 1-to-1 mole ratio, so that needs to be considered. So this formula would not be accurate unless this was a 1-to-1 mole ratio. So let's start with the given information. You have this many moles of barium hydroxide per liter of solution. Okay. And it tells you that you have 27.4 milliliters. To convert milliliters to liters, you can simply take your decimal point and move it 3 places because you're dividing it by 1,000. So this would be this many liters of barium hydroxide solution. Okay, so then these units cancel. Now I've got moles of barium hydroxide. Well, do I have a relationship between barium hydroxide and hydrochloric acid? Absolutely. For every 1 mole of barium hydroxide, I'm going to need 2 moles of hydrochloric acid. So we're going to put that information down here so that we can get from one to the other. Okay, now our moles of barium hydroxide cancel. Now I'm trying to get molarity. Remember, molarity is moles per liter. So I already have moles. I just need to have liters in the denominator here. And I happen to know that I have 0.02 liters of hydrochloric acid. So I'm going to put that down here. It might look weird because there's nothing above it, but again, you're looking for molarity, moles per liter, so you just put the numbers wherever you need those numbers in order to get the answer that you get. When you multiply this out, you get 0.0421 molar, and if you look, you have 3 significant digits in all of these numbers, so your answer will have 3 significant digits. Okay, let's look at another example. Again, you have some given information about one of the compounds and a little bit of information about the other, and so you need to find the molarity. Now, you might not know what acetic acid is, but if you look at this equation, you can tell that this potassium hydroxide, you might not know what this is. You definitely should know this is water, and this is potassium something. And if you looked at your polyatomic ion chart, you would see this is acetate. So you can assume that this is acetic acid since it's the one that you don't know. Let's go back and do our balancing. Potassium and potassium, there's one of each. Hydroxide, and water can be written as HOH, so you've got a hydrogen and a hydroxide. There's one of each. Now there's an H on here that's not there anymore. So that goes over to the water, and then there's 2 carbons, 3 hydrogens, and 2 oxygens. So it actually happens to be balanced the way it is. So let's start with the given information for potassium hydroxide. And again, you might think this is extra work, but it really does help with keeping track of getting the right answer, keeping track of which data point goes with which compound. So we're going to start with the molarity of potassium hydroxide. and that's moles per liter, and again that's for potassium hydroxide. And you happen to know that if you move this decimal place three places over, you get 0.0155 liters of potassium hydroxide. Now I need to go from moles of potassium hydroxide to moles of acetic acid, and it just so happens that there's a 1-to-1 mole ratio of those, so this mole cancels. So now I have moles of acetic acid, and that's good because I'm trying to get molarity, which is moles per liter. So I will divide it by 0.212 liters, and again that's because I'm trying to get these units, and that number was given to me. When I multiply those numbers out, I will get 0.0157 molarity of acetic acid. And again, I use three significant digits because that's what's provided in all of the information in the problem. This mole ratio, by the way, is always an infinite number of significant digits, so you can't think of this as one because there's exactly one of these to exactly one of these, so it's an infinite amount of significant figures. Okay, let's do another one. This is similar to what we've been doing, but there's a little bit of a twist here. It's actually asking for volume in milliliters. So let's go back and make sure our equation is balanced. You have one sodium on each side. Hydroxide is attached to this water. Again, it's hydrogen and hydroxide, an acid and a base. So that's there. You've got a hydrogen over here, which ends up over there, and one nitrate and one nitrate. So it happens to be balanced. So you have this molarity of nitric acid, and you wanted to find the volume in milliliters. Here you've got this molarity of sodium hydroxide and 25 milliliters, and so that's the information. So in this case, instead of starting on this side, you're actually going to start with sodium hydroxide because that's what you were given information on. So I'm going to rewrite molarity as moles per liter of sodium hydroxide, and I know that I have, if I move this decimal place three spots over, I have 0.025 liters of sodium hydroxide, and that gives me the solution, so that cancels. Now I do have a mole ratio. There's 1 mole of sodium hydroxide for every 1 mole of nitric acid. So that's nice because that's getting me closer. Now in this case, I'm trying to get volume. Okay, so I have molarity, so that molarity is going to help me get rid of this moles because I don't want moles. So you could put the moles per liter this way. That's nice because then you're left with liters, but remember it did ask you for milliliters, so you'll have to go one more step, and in 1 liter there's 1,000 milliliters, so then these cancel and you end up with milliliters, which is the unit that you wanted. When you multiply this out, you get 10 milliliters. If you look, everything had 3 significant digits, so you would have to write it in this form. Okay, there's a new little twist that they've added to this problem. They want to know how many grams of potassium hydroxide are required to neutralize this volume of solution of nitric acid. So let's write down the information that we're given. We have 4 molarity of nitric acid. There's 200 milliliters of that. We want to know how many grams this would be required. So let's go through and balance our equation. 1 potassium, 1 potassium, 1 hydroxide, 1 hydroxide, 1 H, 1 H, and 1 nitrate, 1 nitrate. So you're all balanced. Okay, so let's start with the information given. You want grams in the end, so that means if I have a choice of moles on top or milliliters on top, I'm going to go with the moles because I know using the periodic table I can get from moles to grams. So I'm going to write this out. This is moles per liter of nitric acid. Okay, and I can get rid of this liters by using the volume that's provided. This is of nitric acid, so now this is canceled. and this is of solution. Okay, now I have moles of nitric acid. Can I get myself from moles of nitric acid to moles of potassium hydroxide? Absolutely. Simply looking at the equation. So 1 mole of nitric acid is needed for every 1 mole of potassium hydroxide. Okay, so that's getting me closer to grams. So now I just have to get from moles to grams. Well, I know that I can use the periodic table to determine how many grams are in a mole of potassium hydroxide. So when you add those up, you get 56.105 grams. Please do that on your own. Don't just take my word for it. Go back and add that up so that on a test or a quiz you would be comfortable with doing that. When you're done, you get 44.9 grams of potassium hydroxide. So go back and do the math and make sure you get that. Okay, let's do another one of these kind of tricky gram ones. What mass, in this case they didn't tell you what was grams, they just said the word mass, of barium chloride is required to completely precipitate the barium sulfate from 35 mils of 2.2 molar sulfuric acid. So again, what are we doing first? We're balancing our equation. Barium and barium, chlorine, we need 2 chlorines over here, which gives us 2 hydrogens. It works out that there's 2 hydrogens over here. 1 sulfate and 1 sulfate. So now I am balanced. So let's write down our information that we have. Sulfuric acid is 0.2 molar, and there's 35 milliliters of that. And they want to know the mass or grams of barium chloride. So that makes it kind of nice. Again, if you're looking for an answer in grams, whatever your answer unit is, it needs to be in the numerator. So we don't have a grams in the numerator, but we do have a moles that can be in the numerator. So let's start with the given information. 0.2200 moles per liter of sulfuric acid. Okay, and we know that we have 0.035 liters because I converted milliliters to liters, so that cancels. Now I have moles of sulfuric acid. Well, I can't just jump from moles to grams. I have to actually go from moles to moles. Anytime you're going from one compound to any other compound in the formula, you must go through moles. So 1 mole of sulfuric acid, according to the equation, balanced equation, requires 1 mole of barium chloride. All right, so this cancels. Now I have moles, but now I need to get to grams. Again, I'll use the periodic table, the handy dandy periodic table, and I'll add up 2 chlorines and 1 barium. Please be careful that you add 2 chlorines to 1 barium because there's 2 in this formula. So when you do that, you get 208.234 grams, and these moles cancel and I end up with grams. Now put that in your calculator and you get 1.46 grams of barium chloride. And that uses 3 significant digits because each of your given pieces of information had 3